I'm a.k.a. Christoph of HoverAndSmile. On this, our third part of our transmitter series, we'll be looking at dual rates and Expo. We'll learn what this graph means and how by flicking the switches on your transmitter, you can control the characteristics of your flight and even learn how to use throttle hold. Welcome to another of our videos. This one's on transmitters, part 3, dual rate and exponential. This is actually going to be split up into 3 videos, so make sure you know which one you're watching. First video is going to be over dual rate and exponential theory. We'll have some video illustrations, and we'll just teach you what dual rate and exponential are without any specific transmitter programming. Video number 2 is going to cover dual rates and exponential with the DX6i Spectrum transmitter, and video 3 will cover the same topics, but with a Spectrum DX7. So with that in mind, these 3 videos will comprise the entire part 3 of our transmitter series, dual rates and exponential. Before we dive into dual rates and exponential proper, I want to cover a few terms and concepts to make sure that we're all on the same page. Remember that the servos in your RC airplane or helicopter are used through commands from your transmitter to change control surface angles, change the angle of your swash plates, and so on and so forth, to change the direction and flight characteristics of your craft. That being said, each of those servos has their own set of responsibilities. For example, your ailerons, your elevator, your flaps, and your rudder on your airplane are controlled by different sets of servos connected to different channels on your transmitter. Likewise for your helicopter, usually you have 2 or 3 servos controlling the angle of the swash plate, and then you've got a servo for the actual rudder control of your helicopter. Each of those servos has what's called servo throw. That is the distance that that servo arm can move. And when that servo arm moves through commands from your transmitter, that's what's changing the deflection of your control surfaces or the angle of your swash plate. For example, we have a very simple combat foamy flyer right here. Okay? As I move my transmitter stick, you can see that the control surfaces also move. That is done by these servos here. That servo movement can be controlled and manipulated in flight by applying dual rate and exponential. So that's what we're covering here in this video series, is how to take dual rate and exponential, why you would want to modify the characteristics of your servo arm throw and change that in flight. So that's the key definition here, is to know that servo arm throw. And that is when you have your transmitter all the way at one end, the servo arm is moving here, and then when you move your transmitter all the way to the other end, the servo arm is here at its opposite side. And then of course when it's centered for both the transmitter stick and the servo. Now that we've had that brief refresher on servos and servo throw, defining that term, we can now take a look at this graph that graphs servo throw and transmitter stick movement. I'm a math geek, so this kind of is cool for me, but if it's not cool for you in graphs, just sit through it for a minute and we'll go over a video introduction that explains the same thing, but with an actual servo and transmitter. So that being said, your transmitter stick movement is graphed along this line. So if I've got my transmitter stick centered, I'm at this point. If I've got my transmitter stick, say, all the way to the left, it's here, and all the way to the right, it's here. Just the extreme opposite ends of your transmitter. On the opposite line here, we've got servo throw. So when my servo arm is centered, it's here. When it's extended all the way to one position, it's there. And when it's extended to that opposite position, it's here. This graph is very useful for explaining dual rates and exponential. Let's go over your basic default rate. And I call this the high rate because it's 100% of your throw. This means that as you move your stick all the way to one end, that servo arm, for whatever channel that stick is corresponding to, that servo arm is also moved all the way down to its endpoint. And then as you start going towards center, both your transmitter stick and servo arm are centered, and then you reach to the top points of your graph, and you've got your transmitter stick now all the way on the other side, and that servo arm is now all the way to its opposite endpoint. This represents 100% high rate. That's what we're calling it here. It's called the high rate because it's going to be higher than anything else that's going to be less than 100%. That's our dual rate, or our low rate. So this is kind of a default setup, and that just means that however your servo is built and manufactured and set to work, that it's going to move as far as it possibly can when your transmitter stick moves full in one direction, and then the opposite, of course, is going to move as far as it can the opposite way. This can be problematic for first-time flyers because your servo arm, as that moves all the way from one end to the other, your control surface is going to move all the way from one end to the other. And unless you're ready for that, because your flight characteristics are not going to be docile, your craft is going to be a little more stunt-like in its flight characteristics, you're going to have some issues. So what you can do is set up a low rate, and we've got a low rate here. We've just defined this as 50%, meaning half of the throw. The transmitter stick movement remains the same. I start about here, which is about 50% from here to here, so eyeball it, looks about here. This means that if I move my transmitter stick all the way back to this point, when I was set on my high rate, my servo arm moved all the way down to its maximum endpoint. But if I've at a 50% on my low rate, that means the servo arm is only going to move half of what it could before. So it's going to start out here and then go back towards center. And when my servo arm is centered, my transmitter stick is centered, and then go back off to its endpoint here, with my transmitter stick being all the way in its opposite position that it was before, but my servo arm is only moving half as far as it was when I was at my high rate. This is why we set up a low rate and a high rate on a transmitter, so that with one flick of a switch, we could change one channel's servo flight characteristics. And we usually have that separate so that you can control the servo throw for your rudder separate from your aileron and your elevators. These dual rate lines are a really good way of understanding from at least a visual graphing standpoint how dual rate works, because your transmitter stick movement is still full, but your servo arm movement is different based on the rate. Now, below you, you'll start seeing a video rolling along that shows this in actual detail with a transmitter and a servo. So while that's rolling along and my head is now being compressed up to the top of the screen, and we'll go over this one more time as I move the transmitter stick and the servos with my magical other hands. So one more time. By default of a high rate, 100%, you can see that I'm moving the transmitter left and right, or at least I hope I am, because that should be what's happening on the bottom of the screen. Left and right, transmitter stick full movement, all the way across, nice and slow. A servo is moving its arm all the way from one endpoint to another. Okay, now, magic hands, flick the dual rate switch so that we're at a low rate. Now you'll see that if I move the transmitter stick left and right, the servo arm only moves half of its distance that it was moving to prior. This is now set up on the low rate. Doing that to a craft in flight dramatically changes the characteristics.